Hello, this is Mr. Collier, and today I'm going to go over this formative and basically describe what's good about the formative and what could be improved upon. Okay, first of all, your formative needs a title page. Okay, you need a title page, maybe a title and your name. Okay, so I don't know, by Mr. Collier. Maybe you can put the date on there. Maybe that's not important. Depends on your teacher. This is about precipitation. That's a typo there. So maybe you could say, call it Munich temperature comparison or something. Okay, it's up to you to make a title that's appropriate. Or maybe you can, call it, that's not temperature, precipitation. Anyway, you can make a title, whatever you want, and your name's on there. Maybe you put your subject on it, depends on what your teacher requires, but there's not much on the title page, it's just a requirement to have it. Okay, anyway, let's go down to this. So any piece of writing should start off with a introduction. It just introduces the reader about what to expect in this piece of writing. So you should be able to read this paragraph, a couple of paragraphs, and know what is going to happen in the rest of the piece of writing. Okay, so in this report, I'll blah, 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 blah. Okay, so you just describe what you're going to be doing. If you're doing a statistics project, you probably want to start off by talking about the data and how you collected it. Maybe discuss how reliable your data is and what the source of the data is. Okay, and this link should be in a bibliography at the end if you got your source from an online source. Okay, so yeah, you're required to have an introduction, but it's at the beginning of the document, but you don't have to write it first. You have to want to write this last after you finish the document. Okay, just because it's at the beginning of your project doesn't mean you do it first. Okay, with the statistics project, you probably want to start off by doing some things like mean, calculating some things like standard deviation, and it's nice to have it organized into a table, right? So this table could be better. For instance, we could have the units here, maybe July, precipitation, and the units, I believe, are millimeters, so you should always have the units. There's some problems with the notation, like this Q1, that should be a subscript. Okay, and then Q3 should be a subscript. All right. And what else? Standard deviation, you could use this symbol, lowercase sigma. For mean, you can use X bar. So you can throw in some of those symbols, but these are okay as they are. All right, so this is a pretty good summary of statistics here. Nicely organized in the table. Is there anything missing? No, we got range, IQR. I think this is everything we covered. Okay, next, looking at the measures of central tendency, we can see that precipitation is greater in July. Just talk about how much greater, so you can actually subtract these numbers and be more specific, right? So you can say how much bigger it is, or even that is about, looks like it's almost doubled. You could even say something like that. Another thing that can be seen, maybe we could say that, yeah. Let's write that out. Another thing that can be seen, let's subtract those numbers. Let's do that. 3.47 minus the temperature for December is 1.59. That's not temperature, sorry. Precipitation. So there's 1.88 millimeters of precipitation more in December or July than December on average, right? This is an average. Okay, you compare the interquartile range and the range. Okay, they're larger for July. That means you could probably be more specific in saying then July precipitation is more spread out, or less consistent, maybe? Less consistent. So varies, maybe another way to say that is varies from year to year. Okay. Next paragraph talks about standard deviation. So it's 1.14 for July, 0.59, and these have units as well. You can say millimeters. Standard deviation tells us how spread out from the mean the data is. Larger standard deviation is larger spread. Okay. So July precipitation is maybe varies more from year to year. Okay. So it's a bit hard to predict, I guess you could say. So some years it might be less than in December. Okay, the range. Yes, no, this paragraph talks about the range, but doesn't actually talk about the data value, so you need to do that. The July has a higher range. Okay, July has a higher range. Okay, indicating maybe again that July temperatures vary more. So perhaps you could put that into all that information into one paragraph and say that all these things indicate that July temperature varies more. Okay, let me just clean it up a bit. And the interquartile range is also a measure of spread. Okay, and it also indicates that, let's just take a look at the box plot. See, the interquartile ranges are pretty similar actually. Okay, so maybe there's not that much to say about that. Okay, here we have a title. Okay, the axes are labeled. Both the box plots are labeled so you can understand what they are. So it looks pretty good actually. This looks like good communication. Now you got now you should be comparing data values. So like it can be seen that the whiskers of the box plot represents the first 25% and the last 25% are more spread out than the 50% of the data, which indicates the presence of outliers. Okay, there may be some outliers here. You can compare directly. I think we should be comparing directly some direct values, like let's talk about Q3 here. Okay, Q3 for December. December is 2 millimeters. Okay, meaning only, so this here is 25%. Only 25% of the time, or of the years, the precipitation is greater than 2. Okay, however, so compare it to the other one, compare it to July. Q1 for July looks like now we can get the exact value up from here from the table. Q1 for July is 2.8 millimeters. So that means this is 3 sections of the box plot at 75%. 75% of the years, July precipitation is more than 2.8 millimeters. Okay, so make a direct comparison with those values. Okay, so actually this paragraph here says some really insightful things. The interquartile range looks at the difference between quartile 3 and quartile 1. And this is more reliable than looking at the range because any outliers would not be considered, as the interquartile range is only looking at the middle 50%. That is great. Yes, that is true. So this is not including the outliers. So looking at the interquartile range would be better. Looking at our data, it can be seen that the interquartile range are much lower, much more similar, with only 0.4 millimeters difference, which implies the middle 50% of the data is simply spread, is similarly spread. However, July, there are more extreme values than in December, obviously. Okay, so this is a very good paragraph, actually. Now, one other thing you could do with outliers is you can use the outliers, the fact that there are outliers, to, or do we have the outlier formula down here? So if there's outliers, it actually is going to affect the mean a lot. So you can always comment on the mean if you can see that, find the outliers. Let's look down here. We have Q1. Now this should be written as subscripts, right? And the Q3 should be Q with a little 3 on the bottom. So make sure you use proper symbols and things like that. Minimum piece of data is 0.9, so there's no outlier. Okay, so there's no outliers here, but if there are outliers, or maybe you can say this right here, maybe since there are no outliers, the mean is a good indication of the average. Of the average temperature. Okay? Not temperature, sorry. The average precipitation. Okay, but if there are outliers, then the median might be better than the mean. So you can discuss, even if there's no outliers, you can discuss this, what I've written in blue. If there are outliers, you can talk about how the median might be better, than the mean. Okay? Also, the outliers really heavily affect the standard deviation, so you can discuss that as well. Okay. All right, let's look at the cumulative frequency curves. This is very organized. Maybe you don't need X here, probably need millimeters. Otherwise, it looks pretty good. And then the graph, we have labeled on the bottom. That's good. This should be labeled. Maybe you can have frequency or number of years. Okay, because this is number of years or frequency. I'll write number of years. Okay, but you can write that sideways on Desmos if you want. Cumulative frequency graphs of rainfall in July, and maybe should indicate over, it looks like 31 years. Could be a little bit more specific, okay? Or something like that. Anyway, at least it's got a title. So in the cumulative frequency curve, you can make some of these things here. You can discuss percentiles, and because you already had the mean and the quartiles from your box plot, so you can discuss different percentiles with this here, right? And you can discuss the fact that, okay, in July, for the July one, which is purple, like this section right here is very steep. The steepest part of the graph is where you have the most data values, okay? So that's like the modal group. The modal group is from 3 to 4 millimeters. So it looks like for many years there are a lot of data values between 3 and 4 millimeters. Okay. Yeah, you can also say, because the purple line is more to the right than the green line, or the green curve, then it looks like July has a lot more rainfall on average, okay, because it's always below the green one. And you can compare certain percentiles as well. So let's check out what that red one is. Looking at the graph, marking red, there are approximately 24 days in July that have more than 2.5 compared with 4 in December. So they compared, so they compared these two data values, which is a good idea. Draw one line through both curves, and you can make comparisons. You can't do that with the box plot. You can only compare the quartiles and the median. Okay, so that's some good analysis there. Okay. The limitations of the cumulative frequency graph should be considered between each data point. The curve is an approximation. Okay, that's true. So this is a bit of an approximation between these values. So that's good that they've pointed this out. Okay, in conclusion, yeah, I originally thought that there was more precipitation in December. However, analyzing statistics, box plots, cumulative frequency curves, it became evident that it was incorrect. So in your conclusion, reflect on what you've determined through all your statistics and go back to your original hypothesis. Now, if you have a bibliography, like you found stuff online, this should be on the next page, okay? And at the end of your document, you should have an appendix where all your raw data is nicely organized. Maybe I'll put the units in here too. But these tables are much too long to be in the body of the project, so they should be in an appendix.